are quite simple. Though big questions may not come from them, but they are very short mark features for us, because the questions are quite simple in nature from the first couple of chapters, like basically asking you to do some kind of summarization of the data in the form of graphs or tables, or something calculation of some basic things like mean, median, mode. So those are the things that are present as a part of your first chapter. A couple of marks generally come. The first or the second question in any question paper would generally be from these kind of chapters itself. But as we move along, let's say 6th, 7th, 8th, and later on chapters, there is a lot of in-depth of probability and stats that comes into it. But the couple of chapters are more comfortable, so we should not lose marks from these kind of chapters in order to clear the exam. So it is primarily starting with the summarization of the data. The first chapter is on summarization of the data, wherein we have four major sections. The first one being the tabulation part. There are a couple of topics relating to the tabulation and the different kinds of graphs to present your data. Then there is a section that deals with calculations of mean, median, mode, which are called as the measures of location or central tendency. Then there is a section on the measures of dispersion, which is more like calculating your standard deviations, variances, and all. And finally, there is a section on skewness. That is what is the first chapter all about. So if we get started, the prime thing is, whenever we look at any data that comes to us, we can classify it into two forms. It could be either a numerical data or a categorical data. Anything we find in the form of numbers, age or height, weight, anything we find in the form of numbers, we call it as numerical data. Anything that is in the form of text or categories, male, female, yes, no, those are called as categorical data. So every data which we get, probably any data we get, let's say in an insurance company, if we get the claim specific data, right? The number of claims, claim amount, they are all numerical. But type of claim, right, they become categorical. So in every data, every column of data, if we see, either it falls into a numerical category or in a categorical data. And while this subject, probability, or the whole of statistics to a large extent, focuses on numerical based data itself, because for categorical, the maximum things that we can try doing is doing a counting of them. How many males are there? How many females are there? So that very limited in terms of calculation. Whereas if it is a numerical based data, there are a lot of aspects like means, medians, a lot of calculations can be done. So the whole focus is on numerical based data itself, but wherever applicable, we will look at the categorical data also. And within the numerical data, we see that we can have either a discrete data or a continuous. When we say discrete, it is some finite countable data, like number of claims, 1, 2, 3. You can't have 1.5 claim. Not all values within a range are possible. When I toss a coin, 1 head, 2 heads, I cannot get 1.2 heads. But when we, on the other side, when we talk about a height of a person, it could be 170 centimeters, 170.1 centimeters, 170.11 centimeters, depending on the scale of measurement which you are using. It can differ also. I mean, you can have within that range also, not just decimals. I'm not talking just about decimals, but almost any value is possible within a particular range. Probably, between 100 centimeters to 200 centimeters or 220 centimeters, any height is literally possible. Those are called as continuous data, where the number of possible values are very large. Where the number of possible values are very limited, we call that as a discrete data. Only specific values are possible. Let's say when I ask about the age of the person, if I talk about the age in completed years, there are only few. Either I'm 10, 11, 12, 13. But if I say age of the person without saying completed years, then I can say 10 year, 1 month, 1 day. Literally so many values are possible. Then it becomes continuous. So there's the only distinction between a discrete data and a continuous data is in discrete only few set of values are possible where you can do a countable stuff. Though negative and fractions are also possible, but they should be limited in number. Right? When we talk about weight, there is nothing limited. If I go with up to grams, so many are possible. I can even go up to milligrams also. So there are so many values possible. Your weight may be different from his weight. Probably when I use a milligram scale, though both of you may say I'm 70 kgs, but if I use a milligram scale, both of you may be different. Right? So that we call in statistical parlance, that kind of data we call as a continuous data. And we have to understand the nature of the data very well here, because as we move along, when we use probability distributions in future or statistical tools in future, we differentiate the tools for discrete data as well as for continuous data. So any value is possible within a range in case of continuous. Generally, when we talk about countable kind of data, we associate it with discrete. I can count the numbers. Only very limited. Probably 20 values possible, 30 values possible. But if it is a measurable kind of a quantity, height, weight, using some scale, I do a measurement, then generally we associate it to a continuous data itself. And even if I take age without completed years, I'm looking at it as a continuous data itself. And we have different statistical methods for both continuous as well as discrete data. So first, when we are applying, just to give you a very base understanding, there are some probability distributions like a binomial distribution, which are applicable more for a discrete data. But there is something called normal distribution, which is applicable only to a continuous data. Right? Of course, as we move along, we'll